we have our common intermediate language, when it's time to actually run the code somewhere, the .NET Common Language Runtime takes that CIL, or Common Intermediate Language, and turns it into the actual machine instructions that will run on the chip on that particular computer it's running on. So we type some stuff in C#, and we turn it into CIL, and then we turn it into machine instructions when it actually gets run. Okay, let's go to MonoDevelop and actually see what one of those console app things actually looks like. I've started up MonoDevelop, and here's our opening screen. You won't have a list of previous projects you've worked on in MonoDevelop, at least until you've programmed for a little while. So we're going to create a new solution. So up here under Solutions, we'll click New. We are building a console app or console application in MonoDevelop. That's called a console project. So make sure that's selected. And then click the Next button down here on the right. And now we select our project. I'll call mine first console app. And click Create. And so it creates this template for a console app. And we'll go through the pieces here as we go along. So this first line of code is called a using directive. So this system right here is called a namespace. And people write a bunch of code that we can use so we don't have to write it ourselves. Tons of that code comes in C#. And when we get to Unity, tons of that code comes in Unity. So this using directive that says, let me use from a different namespace, lets us use code that has been provided as part of the C# programming language or as part of the Unity engine. We actually by default get our own namespace when we have created this project, and our namespace is the same name as the project name. Now we come to this thing called class main class. And we'll actually talk about classes in the next module, but this is a way to collect together the functionality in our console app. So I'm going to, above the class, I'm going to put 3 slashes. What I'm doing here is I am providing what's called a documentation comment. Documentation comments are in XML. And we can actually use other tools to generate documentation that other programmers can use when they want to use the code that. And being able to automatically generate documentation for the code you write is pretty useful if you distribute that code for others to use. I'm just going to call this first console app lecture code. And so I'll now move to this big long line here that says public static void main string square brackets args. This thing called main is a method. So methods are chunks of code that we call from somewhere to execute the code that is between pieces for that method. And so if I were to run this code right now, I would end up executing this console.writeLine hello world. And why not show you what that does? I've Control F5. It says hello world just like that. Now it turns out in this particular case, this main method gets called by the operating system when we run the code, but you're going to write lots and lots of methods that yourself. Let's add a documentation comment above this as well. And I will just say prints a message. And even though this automatically filled out information about this args thing right there, we'll talk about the specific terminology for that when it matters. I'm just going to clean that up a little bit. And finally, I'm going to get rid of this. I'm just going to make it print a blank line. So what I'm doing here is I am calling a writeLine method on the console class, and writeLine lets us provide output to the command prompt window. So at first, I'm going to F8. You can also select build all, if you forget what the hotkey is for building. But I'll just press F8, and you can see here I get a message that says build successful. Now, you should go do an in-video quiz to see if you understand what really happens when I press F8. Of course, the answer is the compiler generates that common intermediate language that we talked about before we got to actually doing coding. All right, let's actually now run this. So I will Control F5, but of course, if you forget how that works, you can select Run, and you definitely want Start Without Debugging, which is Control F5. So I Control F5, and there you can see the output. It's just a blank line. This press any key to continue comes by default when we run console apps from within MonoDevelop. Okay, so I just hit enter. I press the any key, and here we are back in our environment. And you should go do another in-video quiz to tell me that you understand what happens when we Control F5. Okay, and it runs the common intermediate language that was generated. I'm going to say print supportive message, and I will console.writeLine, and now I'll put the message I want to print out. Remember, by default we got that hello world message, but I'm going to say hi noob, like so. I'll Control F5, and I ran the code, it printed out that message, and we can press any key to continue. Now you'll notice that I did not F8 to build the code before I Control F5 to run it. That's because it's easier to just Control F5 and the IDE build the code along the way before running it. Now you might wonder, how do you know how to use this WriteLine method in the console class? And the way we regularly discover how to use methods is by reading the documentation. So let's go take a look at the Microsoft documentation, and here it is. So in the upper right, we can search on something. So you could search on console class, for example. But look, it even actually gives us a pop-up that says, how about console.writeLine? So let's just grab that. I'll click it. And the documentation gives us a number of results for console WriteLine. Let's follow this one, which is in the console. And here, for a particular class, we get a number of pieces of information. We get information about properties, about properties in detail in the next module. We get information about methods, the methods that we can call on the console class. And so we can make our console beep and so on. But WriteLine, it's all alphabetical, so that's good news. But WriteLine here, and the information that we get tells us both the name of the method and any information we're supposed to provide between those two parentheses. So there's a WriteLine where we don't provide anything, and we used that to print a blank line. There are other WriteLine with different data types that we provide, and we will talk about data types in the next lesson in this module. And down here is the one we're actually calling to print out the string. So the documentation says it writes the specified string value, followed by the current line terminator, so it moves to the next line, to the standard output stream, which for us is the command prompt window. So when we call this method, we put console.WriteLine, open parentheses, we provide a string between double quotes and a close parentheses and a semicolon. The thing that we pass into the method when we call it is called. That's why up here, this auto-generated comment talks about arguments. The only other piece of this puzzle is there's an S over here on the left. And that means that this is a static method, and all that really tells us, all we have to know at this point, is that means we put the name of the class, console dot. We'll see other ways to call methods in the next lesson in this module, but for now, for our first program, we just call this with class name, dot, method name, and whatever arguments we want to provide to that method. This one, we're calling the version of WriteLine that takes in a string. This one we're calling the version of WriteLine that doesn't take any arguments. And that's it. This is our first console application in MonoDevelop. I have provided a copy of the chapter of the book that talks about console apps and the structure of a console app, like the using directives and so on. So you should feel free to download the PDF copy of that chapter for MonoDevelop if you're using MonoDevelop, and Visual Studio if you're using Visual Studio, to get additional discussion about all these pieces of the code. To recap, you can use MonoDevelopment, if you choose to write your console apps and your Unity scripts in this course. You can also use Visual Studio, but I'm going to use MonoDevelop to record all the video lectures for the course. I will, however, provide the code for each lecture and the exercises and the peer reviews as both MonoDevelop and Visual Studio, so whatever IDE you've picked, it should work fine. Providing that code, though, I can't give you a zip as an attachment to a particular lecture because I'm not allowed to attach zip files as lecture resources. So each lesson will have a reading that includes all the code for the lectures within that lesson. I know that's a little less convenient than we'd like, but that's the way it has to work on the Coursera platform. So check the reading in each to get all the lecture code that goes with the lectures in that particular lesson. In this lecture, we will explore a little more deeply how we read documentation. And this is an important skill that every programmer needs. You never reach the point where you don't have to look something up in the documentation, whether it's the C# documentation or the Unity documentation. You are going to spend time throughout your programming life looking up from the documentation that goes with code that others have provided to you. So we're going to explore that a little more here, but you're going to have to just practice. You're going to have to just learn how to do this by doing it time and time again. So let's go to MonoDevelop and solve a very problem that requires us to explore the documentation a little bit. So here's our MonoDevelop project that I created and commented, including this comment that says calculate and print the cosine of 45 degrees. So that is the problem that we're trying to solve. Let's actually declare a float, and we'll just call it cosine. And we're going to need to set it to something, specifically the cosine of 45 degrees. Let's actually just set it to something right now, and this is a temporary thing. I want to show you another important detail about using floats. So let's say I set it to incorrect, and I try to compile with F8. I actually get an error here that says the literal of type double cannot be explicitly converted to float. And it even tells us the answer. It says use an F suffix to create a literal. So when the compiler sees a decimal number like this, it assumes it's a double. And one of the things we're not allowed to do is to put a larger data type, like a double, into a smaller data type, like a float, because 2 to the b equal n, and we know that we will potentially lose some precision when we move from a larger data type to a smaller data type because the smaller data type can't represent as many things. The message here says to use an F suffix, and you certainly can. I tend to use lowercase f instead. So now we can compile fine. We get a warning that says cosine is assigned to, but its value is never used. So let's go ahead and use it. Console.write cosine of 45 degrees. And we'll control F5, and of course we get our output, but it's a lie. So now we have to figure out how we can actually calculate the cosine of 45 degrees. And it's a good time to go look in the documentation. Now, unfortunately, one of the things you have to know if you're going to search is to something, and you have to know what to search for. So let's actually search on cosine, because that's the thing we're trying to figure out. I'll just hit enter here. And it turns out that there's a whole bunch of answers, but the math.cosine method is the one we want. And that brings us right to the method. Now, another way we could get to this method is by actually looking at the math class. So I'm going to scroll down to the bottom here and click math class. So we could end up here. Now, the math class is a very useful class that has lots of stuff in it that we will regularly use as we do math in our games, including calculating cosine and including one other piece that we'll get to in a few minutes. So we could also get to cosine by finding the cosine method from the math class and clicking it. And this brings us back to the same page we were at. Now, there are pieces in this documentation that we need to understand to be able to use it. First of all, we see that it's static. And that means, just like console.writeLine, it means that we will call math.cos by putting the class name math dot in front of the method name. The second thing we see is that it actually returns something. And that's good for us, right? We're trying to calculate the cosine of an angle, and it returns something to us. And so we need to know that it's going to return a double to us because we're going to store that double somewhere. The method name comes next, and then between the parentheses, anything we're supposed to provide. And if you race through reading this documentation, you'll say, okay, D is an angle, great. And you won't read the rest of it because you're in a big rush. And so let's go use the call to this method in our code. So instead of this, we will say math.cosine, the angle, and we said we were going to do 45 degrees. When I compile, it says, wow, this looks a lot like the previous error message, although not exactly. But it does say we can't implicitly convert double to float. Back in the documentation, this says the method returns a double. And here in the code, we're trying to put it so we can use the typecast that we used when we were doing calculations in the previous lecture to say, I want to typecast the double that you returned to me into a float. And I have to do that explicitly because this is a double, so it's a bigger data type. So pushing it into a smaller data type means we could lose some precision. I'm allowed to do it. I just have to explicitly do it. Now, I'm going to Control F5. And if you don't know what the cosine of 45, say, wow, this is great. I got a number and I must have it correct. One of the important things to do when you're doing math and checking your code to make sure it's working properly is you need to know the right answer before you can actually tell if your code is working properly. And I can tell you that's not the cosine of 45 degrees. So we go back to the documentation and read this full comment that says an angle means. We're not providing an angle measured in radians. We're providing an angle measured in degrees. So how do we convert from degrees to radians? Well, you need to know that 360 degrees is the same as 2 pi radians. So 180 degrees is the same as pi radians. And so we need to multiply this times pi divided by 180. And that will convert it to radians for us. And say, well, I know pi, it's 3.1415. While we could get this to work, there's a better way to use pi in our games because, and this is the class, not the cosine documentation, we can see, past all these methods, we can see that math actually provides us a constant for pi. So this is the value we get when we use math.pi. So let's just use math.pi instead of hard coding it in our code. And the way I do it is I say math.pi. Now, I'll make sure I build fine, build successful, I control F5, and I get 0.707, which is in fact the cosine of 45 degrees. So I'm done with this particular problem. And we learned a couple of different things. Importantly, we learned about typecasting something that gets returned from a method, but we also learned that we can read the documentation to find out information about a particular method, like what does it return? What does it require as information we pass in? And we need to pay attention to all that stuff. So that was a very small exercise in exploring C# documentation, but you're going to be doing that as long as you program. You're going to actually be looking stuff up in the documentation, so you'll get lots of opportunities to practice doing that as you program. Last time, the important conceptual ideas behind classes and objects. This time, we'll apply those ideas to actually doing stuff in C. And the first thing that we'll do is we will actually instantiate an object. So create an object from the class. Before we can do that, we need to code or a DLL, but we won't worry about that for this particular class. So this is custom. It doesn't just come in C#. Okay, so here's some documentation, and it talks about constructors and properties and methods. And because this lecture is focused on instantiating an object, what we care about is the constructor. So to find more information about the constructor, we click that link in the documentation, and we get to this page that tells us that we have this constructor, and the important piece here is right here with these parentheses. And so the fact that there's nothing between these parentheses means that when we call the constructor, we don't have to provide any information to the constructor. We don't have to say how many cards do we want in the deck, or what kind of deck do we want, or any of those things. We just call the constructor without providing any information between those parentheses. And that's important because that teaches us how we can actually call the deck constructor. Information, we can now go off and write code to actually create a deck object. Here's our template console app. I'm going to actually start using the deck class. And the way we declare a variable of type deck is just like variables when we were using int or float. This time though, we put the name of the class. Now we immediately see that Intel is helping us here because it auto-filled in with our namespace, and we expected it to auto-fill in with the word deck, the data type for our class. Because this is a custom class that I wrote rather than one that just comes in C#, we actually need to add the source file for that class to our project. So I'll turn on the Windows magnifier and minimize it to get it out of the way. So over here in the solution, this bold-faced item is our project. And if I right click on that project and I say add files, I actually already copied the card, deck, rank, and suit files into the same folder as my program file for this project. So once I've done that, I can open, and those files are now added to my project. I'll get rid of the magnifier tool now. So now when we type the word deck, it actually knows about deck because the deck class is now included in our project. So I declare a variable by saying the type, just like int or float, except this time is deck, and I will call this deck. And let's actually try to print it just the way we have here. So I've declared this variable called deck and call a method on deck. And so I put the name of the object dot the name of the method like so. Now, this is different from what we've done up to this point in the course because we've always put the name of a class here. We've put console or we've put math. And the reason we were doing that is because the methods we were calling are static methods. So we call them using the class name, not an object name. The methods that I've provided in the deck class are not static methods. So we actually need to call them on a particular object in this particular deck. So I'm going to control F5 to run this, and I am deliberately making a mistake here because the compiler tells us I'm using an unassigned local variable deck. So the compiler knows that I shouldn't be trying to print with an unassigned deck object. So I'm going to call the constructor to create an instance of the deck class and put it into this deck variable. And the way we call a constructor is we say new, and then we call the constructor. It is always named the same name as the class. And we looked at the documentation and saw that we don't have to provide any information when we call the constructor. So I'll go like that. I'll just put an open parenthesis and a close parenthesis. I'll F8 to show that it in fact builds successfully, and I'll control F5. And I'll scroll up to show you that it starts at the ace of clubs and goes all the way down to the king of spades. So that's it. We've used the constructor to create a deck object, and we even used the print method to show that we got a correct deck object. To recap, today we learned how to instantiate an object to create the actual object from a class by calling the constructor, and we understood how to do that by reading documentation about that class. That's the first thing we need before we can have objects interacting with each other. We need to actually have objects that can interact. And so instantiating objects